the legend of Chief Sohcah, a young brave of the Tambolian tribe, frustrated by his inability to understand the geometric constructions of his tribe's battle dress, kicked out in anger against a stone and crushed his big toe. Fortunately, the young brave learned from this experience and began to use study and concentration to solve his problems rather than violence. This was especially effective in his study of math, and he went on to become the wisest man in his tribe. He studied many aspects of trigonometry, and even today we remember many of the functions by his name. When he became an adult, the tribal priest gave him a name that reflected his special nature, one that reminded them of the great discoveries and of the event which changed his life, because he was troubled throughout his life by a problematic foot. He was constantly at the edge of the river, soaking his feet in the cooling waters. For that behavior, the high priest declared that the wisest brave shall be called Chief Sohcah. Okay, Chief Sohcah studied many aspects of trigonometry. Even today, we remember many trigonometric functions by his name. Sine, cosine, and tangent. Remember I was talking about those yesterday?
Yes.
Okay. You have these three buttons on your calculator, right? Good. I want to remind you that sine has an E on the end. Okay, sin is why you go to church on Sundays. We have sine, it's pronounced sine. Cosine is pronounced co-sine. And then tangent, tangent. Okay, you will start to see Greek letters. Anybody know what this Greek letter is? Theta. This is theta. Theta. When you see the symbol theta, it's asking you for an angle measure. Okay, in the upper levels of math, they start to use theta, and that's what you're trying to find the angles. The good news is what we did yesterday, you already know how to work all of them. The only difference between sine, cosine, and tangent is what sides you use. You set them up, you work them just like what we did yesterday. You just now have to decide which one to use based on which information are you given. Okay? So, sine is opposite over hypotenuse. Remind me again, what was tangent yesterday?
Opposite over adjacent.
Opposite over adjacent. So, sine is opposite over hypotenuse. Okay? Cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. Okay? Now here's the next part, is we need a way to remember these, which is why we have Chief Sohcah. The sa is sine, which is opposite over hypotenuse. The ka is cosine, which is adjacent over hypotenuse. And then toa is tangent, which is opposite over adjacent. Sohcah. Are we good? So it's meant to help you. Okay. So from there, we're going to move on. And I want to take a look at your notes. Okay. Sometimes they're not going to ask you to actually solve anything. They just want you to set up a ratio. Somebody tell me, what's a ratio? A fraction. So if I set up a fraction, and sometimes I can convert that fraction. But if you notice that, look at this triangle right here. Did they give you all three sides? Yes, they're not asking for anything. If they were going to ask for something, it would be an angle, right? And when you're trying to find an angle, what do you have to push? You wrote it really big at the top of your paper yesterday. What do you have to push if you're trying to find an angle? Second. Very good. Very good. So we have Sohcah, and it will be helpful for you to rewrite this on your paper at different times. So we're going to scroll down to this first section for the example. Okay? Yeah. Okay, the first one says sine of A. Where am I going to put my star? If we're going to use sine of A. By A, very good. So go ahead and put the sign by, or the star by A. What would I call this side right here?
Hypotenuse.
Hypotenuse, very good. What would I call this side over here?
Opposite.
Opposite, because it's across from where the star is. And what would I call this side right here? Adjacent, because it's next to the star. Okay? If I'm going to do the sine of A, remember sine is the S, and it stands for opposite over hypotenuse. What's my opposite side? 5. So this would be the sine of A is 5 over the hypotenuse, which is 13. Very good. In your calculator, all you need to do, because they only want a ratio, they're just asking you to set it up. They're not asking you to solve it. But they also want you to find the decimal form. So in your calculator, do not push sine, do not push anything else. You just push 5 divided by 13. And tell me, what do you get?
0.3846.
0.3846, not 47?
No, that's right.
Very good. Everybody agree?
Yep.
Good. If you didn't get that, did you make sure that your calculator was in degree mode? Okay, because if you didn't get that, then maybe you haven't put it in degree mode. Remember, your calculator must be in degree mode. Okay? The second one is now talking about cosine of A. Where am I going to put my star? At the A, I already did that, didn't I? So now if I'm going to do cosine, remember cosine is the C, and cosine is adjacent over hypotenuse. So the cosine of A, my adjacent would be 12, very good. And over 13, because that's my hypotenuse. Very good. So in your calculator, what's 12 divided by 13?
0.9231.
Do I need to round up, or is that rounded?
That's rounded.
That is rounded. Okay, so I'm just pointing that out because I want to make sure that you're rounding correctly. Okay, I want to give you a second. I want you to try 1 and 2 on your own. Okay, so for number 1, where'd you put your star? At A. What'd you call this side? Hypotenuse. Very good. What'd you call this side? Opposite. And this side? Adjacent. I want to do sine. So remember, if you put Sohcah right here, it might help you. Okay, I'm looking for sine, so it's opposite over hypotenuse. What's your opposite? 30. Good, so you're going to write the sine of 30, the sine of A equals 30 over 34. And then 30 divided by 34 is what? 0.88 what? 24. Okay, did you already do B, or number 2? What's different about number 2? Huh? Okay, it's asking for tan B, so what do I have to do? What? Good, I have to move the star, don't I? So this is still going to be my hypotenuse, but now this is going to be my opposite, and this is going to be my adjacent. And I want tangent, which is opposite over adjacent. So tangent of B, now I'm using my blue letters, right? My opposite would be 16 over my adjacent, which would be 30. So what's 16 divided by 30? One more time. 0.5333. Everybody agree?
Yes.
Good. Try 3 and 4. Okay, the next one, cosine of A. Cosine is adjacent over hypotenuse, so I'm using the red letters. So the cosine of A is 16 over 34. And if I plug that in, what would I get? 706, is that right? Okay, on the next one, cosine of B. Again, cosine is adjacent over hypotenuse, so it should be the cosine of B is 30 over 34. Oh wait, we didn't already have one of those, didn't we? So the answer should be 0.8824. Sometimes we can use cosine or sine interchangeably, because just like if I drive to a friend's house, there's more than one way to get there, and both times I'll get there. So sometimes we can use sine, sometimes we can use cosine, and we're going to work a problem like that in just a second. Okay? But we'll still get the same answer no matter what we choose. Are we good on these? Okay, so let's go to the back side. So right here, they want us to find x. What is x? An angle. So what do I have to think about when I'm trying to find an angle? Second. Very good. That's the first place to think. I might need to push the second function, right? But on this one, how would I find x? Good. A triangle has equal 180, and they've already given me two sides. They will not always give you two sides. But on this one they did, so 90 plus 58 is 148. So 180 minus the 148 leaves me with 32. So this angle right here is 32. Now, just for giggles, these both are exactly the same. So I'm going to write 32 up here. They're both the same. And so I wouldn't have to erase. Now they want me to find y. So my question is, in order to find y, where do I put my star? Doesn't matter. Where would I not put my star?
C.
On C. Very good. I cannot put it on the 90 degrees. So let's start here. Let's put it right here. Let's label our sides. Now we know how to, right? And now what I'm trying to find is y. So I'm trying to find my adjacent. So Sohcah, I'm trying to find my adjacent. That means I'm not going to use sine. Is that true? What side did they give me? The opposite. So which one am I going to use? The Sohcah. Very good. So I'm going to set this one up as the tangent of 32 is equal to my opposite, which is 18, over my adjacent, which is y. Then I would multiply both sides by y. And these y's right here cancel out. And then I would divide both sides by the tangent of 32. Everybody with me? Maybe so. Forget you, Miss Ramsey. Whatever. So push in your calculators. 18 divided by tangent of 32, and you get what?
28.806.
Good. But wait a minute, Miss Ramsey. Hold on. I don't want to put my star there. I want to put my star on the other side. Is that okay? Yes, it is okay. So if I put my star here, I still have my hypotenuse, but now this is my opposite and this is my adjacent. Would you agree? So now I would still do tangent because I have opposite and adjacent, but now it would be the tangent of 58, and my opposite would be y, and my adjacent would be 18. Everybody understand what I just did? So then I would multiply both sides by 18. So now in your calculator, type 18 tan 58. We're not dividing. 18 tan 58. Did you get the same answer?
Yes.
Good. So does it really matter where I put my star? No, as long as they give you the right information. They give you the information to be able to use it. Okay, now I want you to try and find z.
The side.
Z right here. Yeah, the side.